for today, we are exceptionally fortunate to have Noelle and Riaan, the dynamic duo, teaching us all about how to change our minds and also pointing us in the direction of some creative thinking as well. So after the session, what will happen is we'll take some questions and then we are going to hand over to Sasha, who is absolutely tasting the demo gods and will be showing us all of the chaos that Rust has. Feel free to ask questions and jump in, but it's going to be a very relaxed session and we're really excited to share this with you. Thank you for joining us. Thank you for your time. I know that you guys are both extremely busy and both extremely knowledgeable people, so we're sure to learn some stuff today. But I think for now, I'm going to shut my yap, let you guys take over, and let's get started. Alrighty.
I really needed someone to call me dynamic today.
Anytime.
Thank you.
Anytime. Great. It's my biggest pleasure.
Thanks, Janine.
Anytime, guys. Let's go for it.
Great. So, everyone, welcome to our Speakers Forge talk on the Hitchhiker's Guide to Changing Your Mind. For those of you who don't know me, I'm Riaan. I'm a solutions architect at Dariel.
My name is Noelle. I'm a psychologist. I work as an organizational development specialist. So I really have trouble explaining to my parents what I actually do for a living. But here's my best shot. So mostly work with leadership teams, helping them to figure out strategy translation, high performance, I think navigating change and complexity, and really just focusing on strong corporate culture. So that's who I am. So as part of my job, I do quite a bit of thinking and reading and researching, which really is a never-ending pursuit. And as part of this thinking, a friend recommended some of the work by Adam Grant called Think Again. And I've always been a follower of his, also an organizational development specialist, and I can definitely recommend that you follow him on Twitter. And when I started reading this book, Think Again, which is very funny, easy read, not a typical leadership book, so some solid research, so not just fleeting opinions in the book, it got me realizing actually why some teams and some people find it so easy to rethink and have a general openness and willingness to change direction, but then also why some teams or some leaders or some individuals really just have an allergic reaction or a rigidity when it comes to rethinking. So I think the invitation today is really to disengage autopilot and really just, as Douglas Adams says in The Hitchhiker's Guide to Galaxy, we demand rigidly defined areas of doubt and uncertainty. So that is what we want to explore today. And so, Riaan, you think it has quite a few links to the tech environment.
So I've actually spoken to Noel quite a while back already about doing a talk at the Speakers Forge about something like Think Again. And the more we spoke about it, the more I realized how tightly it is actually related to a lot of what we do in the tech industry as people working in technology. Because I mean, all the agile methodologies, and we talk about continuous improvement, we talk about in the Agile Manifesto responding to change over following a plan. So a lot of what we kind of advocate for in the methodologies we use come right back to this as well. So we're going to look at it from two different angles. Noel's going to look at it as more of from an organizational development, kind of a psychology angle, and I'm going to talk about how I see that relating back to technology and the things that we do every day.
So like I mentioned, the conversation or the topic we'll explore today really grounded in Adam Grant's work around Think Again. And just in this crazy space we find ourselves in, whether it's personal or in your work context, just, things are changing so quickly, and how do we actually keep up with an openness to evolve how we show up? And this quote really a good summary. If knowledge is power, knowing what we don't know is wisdom. And I think there's just so much that we don't know when we take on things. So really just, you can find this book on Loot, Amazon, Take a Lot. I don't get commission for this recommendation, but really a solid piece of research-driven work. So Adam Grant explores three lenses of rethinking. Today we'll spend some time on the individual lens, But really the search here or the ask here is let's surface what we don't know. So from an individual perspective, how do we actually develop the habit of thinking again? So not just cruising in autopilot, how do we stop and actually rethink some of our core basic assumptions? From an interpersonal perspective, how do we actually show up and ask better questions and actually have constructive disagreements? There is such a thing as a constructive disagreement, right? And then collectively, using that lens, how do we actually have more nuanced conversations instead of trying to really simplify things to the black and white? How do we actually color it in with a world of gray so that we can actually have deep and meaningful, technically complex conversations? So if you get the book, he spends a lot of time actually unpacking actions for impact. So a way that we make this rethinking thing, not just a theoretical exercise, but some practical applications.
And I think along this line of surfacing what you don't know, the world is complicated. There's a lot that we don't know, and it's perfectly okay to not know everything and to actually admit that you don't, because that gets you to a point where you're more open to learning and experimentation and exploring alternatives as well.
So I think we often faced with new novel scenarios, whether it's a new tech build, whether it's responding to a pandemic, whether it's logging a query with COJ, but we try to retrofit this old tried and tested way of showing up and doing things to novel situations, and it is just actually no longer serving us. So how do we rethink and challenge that a bit? So really the ask here, like step one of individual rethinking is actually let's engage scientist mode. So the shift that needs to happen here is let's shift from whether it's a politician, a preacher, or prosecutor mode to scientist mode. So let's unpack these different modes of convincing quickly. So preaching, and that approach is usually effective when people are open to our viewpoint or they aren't particularly invested. So let's just take the path of least resistance. Let's just proceed, right? And I think it's so easy to fall into that trap. Prosecuting works in situations where the audience is not determined to be in control. I must be honest, I seldomly find that audience. And a political perspective, or taking that politician view, often happens when we want to take a really complex thing, but for the sake of progressing, we need to make it really simple. And we often do this by discrediting our opponents. So as you reflect on your default setting or those people that trigger you in your work groups, you'll probably be able to identify which position they default to. And the invitation here, like I said, is to actually assume the role of a scientist. And we do this so that we can actually invite people to rethink. So the challenge here is not for them to prove why they are right or for you to prove why they are wrong, but actually to help them to rethink. We are able to operate from a position of scientist when our attachment to our ideas are not fundamental to our identities, right? And we'll explore a bit about that in a moment. We can operate as a scientist when we can detach our present from our past. So even if you think, how have you changed the last year? How have you changed maybe from when the pandemic started to where you are now? So to what extent can you actually marry these two versions of yourself? So you don't just get stuck in, but this is the type of person I am and there's nothing beyond those boundaries. We operate as a scientist when we can actually update our opinions when new information or new evidence comes to light. And I think really here to operate an experiment like a scientist, it's important this navigating or operating in the gray. This idea that as a scientist, many things can actually be true at the same time, even though they come across as quite opposing in what they mean. And the importance here that we'll unpack later is this idea of being able to tell a coherent story about how you get to your view or your opinion, but also how this opinion or view evolves. So really the message there is around coherence. And then finally, this idea that who you are is a function of your values and not as your beliefs or your opinions.
And I think the key theme for me around thinking like a scientist is this idea of actually experimenting. So I form a hypothesis. I think for some reason X is true. But before I can make any real decisions based on that, I need to go and prove that idea. And if it turns out that I was wrong, that's fine, because my identity is not tied to my idea. So if someone had to come up to me and say, listen, your idea is stupid, or I don't agree with your idea for reasons A, B, and C, that's fine, because I am a person beyond just the idea. And I think that that idea of thinking like a scientist as well is that ideas are not identity, and our ideas can change, and that's fine. It doesn't impact who we are as people.
I do think scientists might actually ask us to suspend our egos just a little bit.
Exactly.
And that's sometimes the challenge, right? So if we unpack this idea of rethinking our identity, let's just explore this idea of basing your identity in your values versus your opinions. So let's take opinions, right? That can be your view of your past self. We know colleagues or friends or family that show up, in my experience, or we have always done it like X and X and X, or it can even be a strongly held opinion about some controversial topic, right? So if that's where I ground my identity, the moment new information comes to light, it is so extremely threatening for me to actually rethink that. Because if I rethink my opinion, what does that then say about my identity? But if we ground our identity in our values, so for instance, I am curious, I value authenticity and integrity, I value impactful work that makes a customer impact. If we ground our identities in that, it allows a lot of space and freedom for us to actually change our opinions. So the call here is really take stock of your values. I think values is something, I think some of the values we carry are kind of taught to us or imparted on us. But how often do we actually deliberately make a list of that and really understand what is okay for us and what is not okay for us? And just this idea of questioning your assumptions, going, actually, I'm operating on a vast amount of assumptions. Maybe it's time I challenge some of those assumptions and get out of autopilot. The same way we would do a version update of whether it's Spotify or the operating system on your phone. We simply don't do a very deliberate cognitive version update of how our opinions and our values shift over time.
And I think what I often see in technology that I find very strange is how people attach their identity to things that shouldn't actually be a part of your identity. Like if I interview someone and I go, tell me a bit about yourself and what excites you and what you want to do, and they go, well, I've been doing Java for 10 years. Like suddenly your whole identity becomes a programming language. And that is just so weird. And what happens as well then is if I believe that Java is the greatest language ever and nothing else can come close to it, it means a part of my identity is I need to pick fights with .NET people on social media. And it means that if Sasha is doing a talk about Rust later, I'm not going to be receptive to listening at all because I've already formed an opinion. I've attached my identity to this opinion, which means it's going to be very difficult for me to consider anything that isn't this thing that I believe to be true. Mm. And I think there's a lot more to your identity, even as a developer, than just I do Java. It's like I solve real business problems using logic and critical thinking and problem solving, and Java just happens to be a tool. So I think we need to be very careful that we don't grow too attached to something that's really just a component of our work, but that has very little to do with who we actually are as people.
So the key takeout here really being keep an active list of what would help you change your mind. So what is the evidence you need to change your mind? And just remembering the stronger your attitude towards a certain outcome or opinion, the less likely you are to rethink, because we kind of hunker down and it becomes this protective mechanism because our identities feel threatened if it's grounded in opinion rather than value. And so I referenced this idea of freedom to rethink and the importance of telling a coherent story. And this idea that I think we often see that when we are in a space that requires a very time-limited outcome and we need to perform and we just need to go, go, go. And it's this complex thing. So we just need to kind of pick a view and stick to it. And that then becomes the hill we die on, versus this freedom to actually go with some transparency based on what I know now. A, B, C, D, and E is the decision I make, in a month, when we know better or differently, we are going to revisit this decision, and then we're going to possibly decide 1, 2, 3, or 4. And I think that gives us a lot of freedom to actually change our minds, because we now know better or know differently. Because face it, a lot of the work we do, there are just so many unknowns and undefined things. And I think a lot of this idea that, you can't change your mind, it makes you fickle, pick a lane. Like, I don't know that we actively choose that for ourselves, right? So yeah, the important message here is actually changing your mind is okay in light of new evidence. It does not make you fickle. The important part is that you can tell yourself a coherent story, or your team or your business, of actually A is where we started. All these things happened. We now know differently. So B is the end result, or B is where we start making different decisions. So that coherence, story that makes sense. So some things that we can ask ourselves here is, what's, when you get triggered here, or do you feel like you can't rethink, is what story am I telling myself about the situation? How am I limiting myself in this situation that there's actually no freedom for me to rethink? And then again, what evidence will actually change my mind? And the importance of actually, let's be more transparent in surfacing our thinking to our teams or our colleagues.
And I think even in something as simple as debugging, like you ran into an issue once where there was a performance issue because something in a database wasn't indexed, that kind of becomes your default when you investigate a new issue. But it's very important to go, based on what I know now, I think this might be an issue. Here's my approach for actually proving whether or not it's an issue. And once I've done that, either I go down that route and I fix it as a database issue, or I start exploring something else. So it's also back to thinking like a scientist. Before I jump to a conclusion, how do I actually test it? It's a bit like, you don't want to lose your car keys in the street, but look for them in the kitchen because the light's better there. You actually want to be deliberate in terms of how you go about things, and be open to trying new things, exploring new theories, and not getting attached to an idea too quickly.
So Adam Grant also makes this important comment around, actually don't confuse confidence with competence. I think often in fast-paced environments, confidence really gets rewarded, but I mean, you can also be confidently, profoundly wrong, right? And he speaks about this getting stuck at the summit of Mount Stupid, which correlates with your willingness to have an opinion on a topic, but also your knowledge of that topic. So do you ever get stuck on Mount Stupid, Riaan?
So I think if I reflect on my career, there was probably only one point where I knew everything. And that was probably for the first 2 weeks after I started working, because I had just finished studying. I got the piece of paper at the end and it said I'm smart and I know everything that I need to know and I can go into my career. And like, I went into my career because I'm smart now, I know everything. And then as soon as you get exposed to the real world, and this context is suddenly different from when you were studying and everything was fairly well defined and rigid and someone had to mark it so there was a right answer at the end, the real world looks very different. So I went into it with a lot of confidence, but that got shattered fairly quickly, which I think is a good thing, because this position where your confidence outweighs your competence is an easy way to get yourself into a lot of trouble that you can't get out of, because again, you're so competent that I must be right because I know exactly what's going on. I think the flip side of this, and that's unfortunately something that happens in tech quite often, is imposter syndrome. So there's this one scenario on the peak of Mount Stupid where your confidence outweighs your competence. But then you've also got the other problem where your competence outweighs your confidence. So imposter syndrome is a really nasty thing that I think happens quite often in tech. And people are successful because they are competent, but somehow you still feel like a fraud. So you feel like it's mostly luck that got you to where you are. And at some point, that luck will run out and everyone's going to know that you're clueless. But then your boss still comes to you and says, well done, you did a great job at doing whatever. Or you've done well this year, here's an increase or a bonus. And throughout all of it, we're still just sitting there thinking, but I'm actually clueless. Why doesn't anyone see that I'm clueless? But that is really just a case of your competence actually outweighing your confidence. And as much as we think that imposter syndrome is always a bad thing, there are actually some benefits in it. It tells us that, there's always an opportunity to learn, because I know that I don't know everything. I know that there's still more to learn, and I know that that is okay. That's just the way the world works. I'm never going to know everything. It also allows us to work both harder and smarter, because again, it forces us to reflect. So however unpleasant it might be, there's a motivational component in it that prompts us to rethink. And it actually makes us better learners as well, because it means that we're open to learning. It means we know that we don't know everything. And as soon as I get to that point where I believe that I know everything, it's going to be very, very difficult for me to learn anything else, because I just won't be receptive to it. So yeah, as much as we think about imposter syndrome as always being a bad thing, and it is very unpleasant, I think there is some value in it that we should probably focus on as well.
I think it's a really meaningful, almost prompt when we are on autopilot and we start feeling, okay, I'm going to get found out any moment now. Actually, what don't I know enough of in this situation? Where do I actively need to fill my skills, get more experience, network or stakeholder manage better? I think it's an interesting reef of imposter syndrome. I also really like this, embracing the joy of being wrong. I think especially as technical experts or specialists, I think often the room defers to our knowledge and our expertise and our opinion on how to proceed. But really, which links to that, almost that how we so easily get stuck at the summit of Mount Stupid. But here, Adam Grant talks about embracing the joy of being wrong, and really referring to, it takes curiosity to learn, it takes courage to unlearn. Learning requires the humility to admit what you don't know today, and learning requires the integrity to admit that you were wrong yesterday. Learning is how you evolve, unlearning is how you keep up as the world evolves. And there's just simply no way we can keep up with the pace at which things changes if we're not actually willing to unlearn. And I know this for you has very particular meaning around this concept of failing fast or learning quickly in the context of project.
I think it's in some ways it feels so easy and straightforward to actually buy into this philosophy, but in practice it can become very difficult. Because I mean, if you write a piece of code and you do test-driven development, you write the code, you run it, the test fails, you fix it, that's very easy to accept. It's like that's failing fast in the way that makes sense to all of us. But if you then zoom out of it and you start looking at projects, this idea of failing fast actually becomes a lot harder, because we take something on because we've got this belief that we can do it and that we can succeed at it, and that belief almost becomes a part of us. And to then get to a point where we want to step back and say, actually this project isn't going to work, or actually the way that I'm trying to do this thing just isn't going to fly, because we're so driven to succeed, and we've really attached ourselves to that idea. This idea of failing fast in that context actually becomes a lot harder. And I think it's important to just remain open-minded and actually think like a scientist and be able to step back and go, as much as I believe in this and as much as I want to make it succeed, if I reflect on it, is that actually still the right way to go about it? And failing means we sometimes have to admit something to ourselves that we don't really want to, that I was wrong in taking this decision and thinking that this can be done. But again, see it as a learning opportunity.
I like also the reference to joy. I suppose the joy referring to actually when you are wrong, know that you've just learned something. So yeah, interesting take. Okay, so then let's also explore this idea of finding your confidence sweet spot. So we spoke about getting stuck at the summit of Mount Stupid and this interplay between confidence and competence. Let's also explore this idea of your belief in yourself, whether that is secure or insecure, and then opposed to your belief in your tools, whether that is certain or uncertain. And really the confidence sweet spot there is in confident humility. And I really like that term because it speaks to actually I'm confident and I'm grounded, but I also know that there's actually never an end point where I actually arrive and I now know what there is to know. So it also speaks to this idea of mental flexibility and really lifelong learning and how we must harness the benefit of doubt. And like I said, it's not about arriving at the ultimate answer, being open to change your mind when there's new evidence, and actively actually searching for reasons you could be wrong. So Adam Grant recommends that the highest risk here is when you feel like you've reached the point of ultimate mastery. And the sweet spot for confidence is really grounded in your goals, but a humble questioning of your tools. And I think Riaan referred to that earlier. And further, he goes on to explain, well, Adam Grant, not Riaan, that the rethinking sweet spot varies, but typically it is about rethinking something about 4 times is that sweet spot. And really, you know, the degree of humility it offers when you are open to rethink your views. So a piece of research that Adam Grant also surfaces in the book is this idea of inviting feedback and constructive conflict. And he explores actually how this plays out in low-performing groups and high-performing groups. So there are 2 modes of conflict that we explore here. So there's relationship conflict and task conflict. And it's really around this idea that we learn more from people who challenge our thought processes than those who affirm our conclusions. So in poor performing teams, what he found is that typically they start with more relationship conflict. They enter into interpersonal feuds very early on in the working relationship, and they're so busy disliking each other that the task at hand or this thing we're working in service of is actually not challenged. By the time all the relationship drama is challenged, it's actually too late to rethink the task direction. So conflict, that interpersonal relationship conflict is maintained, so it becomes about us, not about the thing or the outcome. And really the debate here is emotional, and we are really unable to rethink when we operate in that space. For high-performing teams, he found that actually they start with low relationship conflict, and that is actually kept quite low throughout the working process or working together. But interestingly, there's high levels of task conflict at the outset, and where really competing perspectives are surfaced in a robust way. Teams are then able to align on a direction until new task issues appear, and then we go through the required debate, but relationship conflict remains low. And the debate in a high-performing group is actually intellectual debate where more creativity and smarter choices are unlocked. And then linked to this idea of task and relationship conflict, he also toys with the idea of actually what would happen if we actively surround ourselves with a bit of a disagreement network. Instead of agreeable cheerleaders. I mean, we all need our agreeable cheerleaders, but what would happen if we actually go and look for those people who won't just go along with our view, who will actually challenge us to rethink, who will not just tell us what we want to know.
And I think to try and bring a lot of this back to the world of technology and the things we deal with every day, looking at it from different perspectives. So if you look at just writing a piece of code, and if you run into a bug and you're trying to debug this thing and it's a mission, you don't know what's going on, it's actually a lot like reading one of your own emails. Like you tend to skim over all the issues and all the typos and you don't see it until you eventually send it because you've written it. You know exactly what's going on there. But as soon as you go to someone else and say, listen, I've got this bug, can you please come and look at my code and I'll tell you what's going on? And you start rethinking it in order to explain it to someone else. Suddenly you've got that aha moment. Like how often have you called someone over, started explaining the code, and then go, okay, I've solved it, you can go away now. And it's just that act of actually trying to explain something and talk someone else through it that forces you to think about it differently. Also, just being able to actually step away from a problem, clear your mind, come back and look at it with fresh eyes. Like that often helps as well. And then we've got this idea of best practice. Somewhere at some point we do something or we read something and we decide that this is going to be the best practice going forward. But how often do we actually stop and reflect on that? Like the thing we deemed to be best practice in a project 2 years ago, in the current context, does that still apply? Like, do we ever reflect and ask those questions? And then if we look at it from a project perspective, we often talk about Agile, we talk about Lean, we talk about this idea of continuous learning and continuous improvement. The Agile Manifesto says we value responding to change over following a plan. The Agile Manifesto principle says that we welcome changing requirements even late in the process. And when that actually happens in practice, we get very frustrated. But I think it's important to just reflect on it and actually see the value that this change is a good thing. We change because we're learning something in the process and we're adapting and adjusting to that change. There's also, out of all the Agile methodologies, in my opinion, if you want to take one thing out of it and only apply that in your teams, it has to be the retrospective. Because, I mean, that is a whole meeting that's actually dedicated to learning, to reflecting, to improving, and finding ways to do things better. We also talk about minimum viable products, and this is very much grounded in thinking like a scientist, because the idea behind MVP is we come up with a hypothesis, we build something, we put it in front of someone, we test that idea, and then either we do it or we pivot. I think what happens in practice, and where we often get it wrong, is an MVP becomes almost like a project plan. So you talk to someone and they say, well, we've mapped out MVP 1, 2, and 3, and suddenly we've designed the thing we're going to build a year down the line, but we haven't tested the original idea yet. So we're missing the value in the approach that we actually try and follow. It's also important to actually understand the other side of the equation if you're writing code, because ultimately everything we do and everything we build exists to solve or serve some kind of purpose in a bigger business. And I was actually in a conversation recently where we had a piece of code, it wasn't necessarily optimal. So then looking at it purely from a developer's perspective, we can say that I don't actually like this. I think we should wait and clean it up before we deploy it. But if you then sit down and talk to someone from business and they say, well, if you can get this into production right now, it's going to save us 5 million rand. Suddenly having that different perspective and understanding why someone else cares about this helps with our decisions as well, because then, I mean, it makes sense to deploy that code and we can come back and fix it later, or we can come back and refactor it later. I'm not saying we should write and deploy poor quality code, but I'm saying that we should understand the broader context and what it means for someone else as well. If we look at architecture, we've got this whole concept of evolutionary architecture, and what that comes down to as well is we don't actually know everything. So let's design for what we have right now. The decision we don't have to make right now will defer. And when we defer decisions, we allow ourselves to learn. And by the time that we eventually make that decision, we've got a lot more information that actually factors into it. So the longer we wait and the more we learn, the better the decisions that we can ultimately make. And I think as a manager or as a leader, the things that help your teams to do this is firstly create a safe environment. Allow people to speak up, to raise their views without fear of repercussions, or it's going to reflect negatively on in my performance review because I criticized my team lead or something like that. So a leader should create an environment that is safe for people to speak up. We should allow failure if that failure means that learning comes out of it in the process. I think a team that's too afraid to fail is also a team that's too afraid to experiment and too afraid to try anything new. So there's very little that happens in the way of improvement if we're too afraid to actually try something new. Also, for a leader, ask why. Ask why to yourself, ask why to your teams. If we do something in a particular way, why do we do that? Is it still the right way to do it? If someone in your team comes to you and says, why do we do it like this? Don't just kind of brush them off and say, because we've always done it like that, and I'm the boss, and I said that's the right way to do it. The fact that you're the boss doesn't mean you're the only one who gets to have an opinion. I think going back to the previous slide and what Noelle spoke about, it's very dangerous for a leader to surround themselves with what we call yes men. So people who are always just going to agree with you, because it's healthy to have some task conflict, to actually argue about the ideas without attacking the people behind the ideas. And then finally, create a learning culture, create a culture where rethinking is actually more likely to happen because it's the kind of thing that we promote and that we value and that we believe in. So yeah, that's my take on it from a technical perspective. Noelle, do you have any closing comments?
So I think just really this question, what do you need to rethink? And I really cracked up when I saw the Windows 95 example because I remember it so vividly. I'm sure there's like a very young grad sitting here going, Windows what? But anyway, just what do you need to rethink? And just this need to update your mental maps, and just the reflection, what deeply held views or assumptions are simply no longer true and no longer serve you. Cool. I think that's us. I don't know if we have any questions.
Thanks, everyone. Thank you for your time.
Right. Yeah, so we've had a lot of chat and a lot of comments. I must admit, quite a lot of interesting ones. Something I wanted to sort of just run past both of you is, how frequently do you look at maybe doing like a career check where you question, the way that you're doing something in your career? Have you done a career checkup professionally with someone? And what did you learn from that experience?
So interestingly enough, Adam Grant in his collective rethinking actually refers to go to your calendar right now and schedule a career check-in with yourself 6 months from now, 12 months from now, and ask yourself a few questions. Are you still learning? And is what you are busy doing still aligned with your values? And I think that's quite profound. And I think a lot of us fear the existential dread that would happen if we really did that. It's easier almost not to have that check-in with you, but I think really important for us to do that. I think what we've also seen over probably the past 2-3 years, people being more willing to actually go, is this still serving me? Just because our beyond work context has shifted so much. I don't know if you've experienced any of that.
I think it's important to some extent hold yourself accountable as well, because I mean, ultimately we are responsible for our growth and our careers, and we need to know, what are the objectives that we're working towards? Is the objective that I decided I actually want to do 3 years ago, is that still relevant? And if it is, what am I doing every day that actually allows me to get closer to that? And is there something where, going back to one of the first slides, where I have to say, I'm going to disengage autopilot now, and I'm going to go talk to someone and say, this is actually not what I need right now. Please, can you help me?
Absolutely. And I think to a degree that speaks to the value of having a mentor and having a good support system as well, and someone to just speak to in that context. So one last question, and this one's more for you, Riaan, but Noelle, feel free to jump in. But
I'll surprise you with my tech knowledge.
I'm sure you will, because you sit in on most of the meetings. You lived through a pandemic with Riaan. I know you're fine. So I'd love to know, in terms of our day-to-day practices, we spoke a little about Agile, we spoke a little about looking at MVP and all those sorts of things. In your opinion, what is the tech-based practice that we probably should rethink that isn't serving us anymore?
Sure, that's quite a loaded question.
That's an interesting one. The tech-based practice that isn't serving us anymore. There's probably a few. I think a lot of them probably do relate to project management in some way, because like I said, we tend to miss the plot completely with MVPs. But I think one of the ones that really stick out is we do Agile for the ceremonies, but we disregard the values. So we have stand-ups, but we have stand-ups because someone said we should, and then we sit in a meeting and just, I don't know, review a spreadsheet for 30 minutes, as opposed to actually going back to the core purpose of this meeting is to collaborate. So it's important to go, are we actually achieving the thing we want to achieve here? Or are we having retrospectives because it's a KPI for a project manager somewhere that the team should say they have retrospectives? Or are we having retrospectives because we actually actively work on improving a team in the process? So I think it's that idea of getting out of the mindset of just doing things because someone said we would or we should, and actually doing them for the real value that we get out of it, and continually questioning whether or not we're still getting value out of it.
Yeah,
I think one of the other tech things that came to mind as well is if a manager tells a team you need 100% code coverage on your unit tests. That's kind of a ridiculous goal, because there are things that just won't ever happen because it just won't. There's catch blocks that you'll never reach because the condition is there because the compiler enforces it, but it can never happen. So then we end up going down rabbit holes and building code for unlikely scenarios because someone said we need 100% test coverage. Just as a show of hands, have any of the teams run into that recently? Looks like it's just me.
No, we also have Bill as well. So, I mean, maybe there's some commonality in the origin of this observation, but we'll leave it at that. But this was amazing. You guys are fabulous. Thank you so, so much. If you guys have more questions, pop them in the chat. The conversation does not stop, but we'll share the session as well going forward. And thank you for your time and your effort, despite all of the mountains of MBA research that you're both doing. I'm so proud of you. I'm so happy that you're both here. So thank you for today. I think let's hand over to Sasha and go to the cowboy side of things for a little bit.
Right. Thanks, everyone.
All right. Sasha, over to you.
How's it, guys? Okay, so we're gonna switch gears quite hard here. So we're going from human skills directly into technical skills. And I don't have a palette cleanser. I don't even have a joke. So I'm just going to share my screen and then dive right into it.
Go for it.
All right. So I have recently rediscovered Rust, and I wanted to do an evaluation for TechRadar, which is the internal program for Dariel's emerging technologies. And Rust is quite mature these days, and I thought we'd start with an interactive example of running a Hello World on the Visual Studio Code. So we could do this through the CLI, but it's got this like cool little button here. So I'm just going to run it, and there it's going to run cargo, and it's going to package the Hello Rust program. And then it's going to run it from the binary folder, and it's going to print Hello World, which is standard kind of Hello World stuff that we have seen many times before, and it's not that new or interesting. So what makes Rust different? Well, first of all, there's this little exclamation point at the end of the print line function, and that tells us the this function panics, which is Rust's way of throwing exceptions. So if you're familiar with Java or C#, you understand it as this idea of throwing exceptions out of your program. And the way Rust does that is through this idea of panicking, right? So if writing to the standard output input and the standard input output library fails, it will then panic, and we'll see some panics, I'm sure, during this demo. Rust is quite different from the call them garbage collection stack programs, in that it comes from the embedded systems world, right? So this was the Mozilla Foundation came up with Rust because it had to deal with a fair amount of embedded systems programming on the operating system level when delivering Mozilla. And so you'll find that it mimics some of the concepts out of C++ world, where you do get to manage memory manually. In a sense, you have to allocate memory. However, this memory allocation is sane. So unlike C, where you're bound to do some null termination string stuff when you've been exposed to enough C, in Rust, you have this idea of managing memory by allocating memory based on types, right? So, and you can see here that like my IDE is telling me that the inferred type here is U813. So it's this ampersand in front of the square brackets tells us that this is a reference, right? So if you're coming from the C# world, you'll kind of, everything is passed by reference, right? Java, C#, everything is passed by reference. Here you have to stipulate that this is in fact a reference type. In other words, it's going to go on the stack versus a type that's going to go on the heap, right? Where the memory address is going to reference the memory allocation for the type directly. And if you're coming from the C++ world, you might get confused with pointers. It is, in a sense, you can think of it as a pointer. It's just that it's not a pointer where you have to do pointer arithmetic, right? We're just literally saying this is a reference type, and therefore we will reference it from the stack. So now when we rerun our Hello World program, we can see here that I am now assigning so this U8, okay, cool. Let's maybe talk about U8. So Rust has a lot of primitives. Okay, so U8 is an 8-bit unsigned integer type, and that's a primitive. And so what I'm going to do is I'm going to, and we don't need this anymore, right? So that's kind of just a distraction. So I'm going to assign to the variable out the value of hello world, and this is shorthand, which is going to translate each and every one of these characters into its Unicode 8-bit equivalent. So this is going to be a vector or an array of unsigned 8-bit integers represented by the string. And that's just a shorthand location. So in order for me to utilize the panics printline function again, I now have to convert the vector, right, into a reference to a str. And it's different from string. And we're going to get into what are they called in Rust? We'll get to that later, the difference between str and string. Okay, cool. So the string arithmetic works differently, but before we get to it, there's this package manager solution called so everything in Rust runs through this tool called Cargo, and it does package management, compiling, all that stuff. And this is Tom's obvious minimum language format, because we don't have enough markup languages. We also have TOML, and this is where you'll manage the dependencies for your Rust programs, and then Cargo will pull those dependencies in and then use them at compile time. So there is this now cool little Ferris says say function that works through using the vector of unsigned integers to put the output of max worth and a reference to a mutation W, which is a buffer writer for this. Like, there's a lot of typing going on here, and the type safety is really important in Rust, and it gives you almost like a pre-unit test ability to kind of put a lot of type safety into your program by default. So for instance, so we're going to run this now, and then it's going to where are we now? Okay, so I don't know if you guys can see it, but it's got like a cool little hello world crab kind of way of doing the greeting, which is super cool. But like what makes it interesting is that, for instance, and with the modern IDE, again, I can insert an explicit type here, right, on my type allocation. And that means that, like, if I want to change this greeting, right, and I want to say, instead of hello world, or I want to say hello Sasha, in so doing, what I'm going to do is I'm going to break the typing system, right? So the compiler is going to catch this and say, well, I'm expecting an array of fixed size of 13 elements, and I found one with 11, right? So it's almost like if you were running your unit tests, it would literally inform you of, and what does that allow you to do? Well, it allows you to then put in the explicit typing, right, where you expect somebody else will edit the code down the line, right? But if you don't want to do that, then you can just remove the typing, and the typing system will then automatically infer the type, right? So at compile time, it will assume that you know what you're doing, and therefore you don't have to enforce this rule, and now the test passes, right? So that's kind of cool. However, when we're dealing with like client requirements and stuff, we're typically dealing with real business world stuff. So where does Rust fit into this? Because it comes from the Internet of Things and embedded systems and kind of running code on fridges and toasters and whatnot. So this idea is now kind of not translatable necessarily to the world of web APIs, where our clients want us to, for instance, expose an API endpoint and have it open to the internet, right? Like, how does Rust fit into that? Well, for this reason, I think let's move on to a more complicated example. So this is a to-do list, right? So what we're going to try and do is we're going to run this little program here, and what it's going to do is it's going to manage a to-do list, right? Which is a kind of a standard Hello World 2.0 for like the web, in a sense. Like, we all had to build like to-do lists to familiarize ourselves with a new technology stack. So if we just run it now, unfortunately, there's an action and an item, right? So my program is now panicking and it's panicking at please specify an action because I'm expecting an argument, right? So we can't just Soma run it. So what I did previously is I ran the command with the item to add an item called watch video, right? So what this did now is it ran the program, and in the so there's my little database of Rust to-do items, and it's obviously encoded for like the Rust CLI kind of story. But we can see that I can add the watching on video. So how does the action add work? So it works with an implementation through a struct, right? So structs are not quite the same as structs in C, C++. They're, I would say, almost like interfaces in C# or Java, where you get to create a definition of something and then implement that definition, right? So this to-do struct has an implementation with a few functions, and one of the functions is a insert a key, right, into the to-do database. And then Rust does this quite a lot. There's this matching function, right? So for instance, the save returns a result, which can either be an empty function or an error. And this is kind of how it borrows this, I think, quite a bit from like Haskell and this idea of like optional, where a function returns a type, and that type is either the expected result or the unexpected result, right? And it gives you this behavior by default. So in this case, like, we're going to try and save an item, and if there is an error in saving the item, we're going to throw an error, right? So if you look at the insert function, it's actually a pretty simple implementation. It just maps to itself, right? So within itself, it has a hash map for strings and booleans, and it inserts the key value of true, right? So that's pretty obvious. The save function is way more interesting, right? Because we have this like content pushing of records within the function, and then we have to also write to a file, right? And it has a standard file system writing technology. And then we can also complete items. So I'm going to complete the item for watch video. And there we have. So now I've completed watching of video item on my to-do list. And so that will now basically complete the item, and the complete function demonstrates that there is now a match on getting the mutation. And if we find the mutation, then we put a sum of the false. And this is, again, like very Haskell-y or F-sharpy if you've dealt with those functional languages. Rust borrows a lot of these concepts. And also change the methods quite a lot. So it's almost like it has this promise kind of syntax to it, which I think is quite cool, because these programs look like functional promise in a way, but you're dealing with embedded systems programming, and you're managing memory, right? So if you're looking for something that needs to run. And let's have a look at the final example. I won't bore you much longer after this. So there's a JSON program here as well. And we'll just clean it up. Again, in principle, the main program hasn't changed, right? Because we still have an action to add and save. We still have a complete, and the construct is the same, whereby when we get a sum, we do save. Otherwise, on an error, we don't save. And it's only the implementation and only within the saving function, right, where we're now kind of opening this db.json file and managing it. So that kind of works. So we can also like add a watch video item to the JSON version of this program, and we can also complete it. And then when we look at the db.json, right, we've got this watch video item in our to-do list, and we can add other stuff to our to-do list. So it's like finish talking, for instance, because I think I've been at this for like way more, but it hasn't been completed because I'm still speaking, right? So it's still got the attribute true. So this example, I think, of write, create, open, right, and then there's this like quirky little question mark, and that is because the open function returns a result, right? Because it might not find a file, it might throw an error. So what we're doing is we're saying like, well, you can unwrap that, right? And then you can get the file, or you can use the shorthand and just put a question mark there, and then you'll get the file out of the result. So that's Rust in a nutshell. And I think I can stop sharing and open up the floor to questions if there are any Rust experts. It is a command line interface programming thing. So where you would use it for our clients is like you can put in a container, right, on a container orchestration platform, which is, let's say, Kubernetes, a little Rust program where performance is like of issue, and it has a rich library support. So if you need to connect to a database in that Rust program, no problem, you can do that. You can extract and write to the database, all that standard kind of CRUD stuff. But like where performance matters on the container itself, and you need to squeeze in last bit of processing, this is where I would use Rust, right? So this is like a container CLI program for your microservice, and the emphasis would be on microservice, right? So your Rust program would be very, very short. It's not for like these monolith microservices that become bloated over time and turn into yeah. Anyway, cool. Let's open up for questions.
All right. Let's see what we have. I mean, as a start, really interesting stuff. Also, to everyone, if you are into researching and helping Sasha find more cool things that maybe could be worth our exploration, hit him up, talk to him about the Tech Radar. I think there's a lot of room for really interesting research. If there are questions that come through later on, we can also do that. But otherwise, you guys were awesome, Sasha. That was really, really cool. And I can't believe you actually wore a button up. You came prepared. You're looking professional for today. I appreciate it.
I'm on site.
I mean, on site and on fleek. Both of those things are true. So, friends, thank you for today. I think let's wrap it up for now. If there are additional questions, let us know. But otherwise, we'll see you in the next session for the Forge. And thank you, Sasha. Thank you, Noelle. Thank you, Riaan, and everyone for spending your lunch with us. This session will be recorded. Well, it is recorded and it will be shared very soon. But we'll see you guys in the next one. I see there's a little message in the chat. And again, thank you so much for today. See you guys soon. Bye.